H2O3, removal of off-flavour in farmed fish and saving water. Located on Bornholm, a beautiful island of Denmark, we find Bornholm Salmon Hatchery.
In this facility at Bornholm, we have already shown that it is possible to remove geosmin from the water. And the next step will be to finalize the development and make the device marketable.
Jesper Heldbo from the Danish industry organisation AquaCircle has gathered 3 companies to conduct a project to demonstrate new technology for the aquaculture, able to remove geosmin in water of land-based fish farms.
Recirculated aquaculture system is the most sustainable way to produce fish. And in the system we clean the water and we keep the water quality in optimum conditions for the fish we farm. We do that by using mechanical filters and biofilters. In the biofilters there's a lot of bacteria that clean the water for us, but unfortunately some of them also produce this geosmin, which may create the muddy taste in some of the fish. And by trying this new developed equipment, we have proved that it's possible to remove the geosmin from the water.
The tests have been made at Bornholm Salmon Hatchery, where they have the facilities to perform them. First, it was tested in fresh water with the small fish.
The equipment is actually an ozonation followed by a UV treatment. And we also have a brand new ozone probe that secures that no ozone is going into the fish in the tanks. So we will treat some of the water and keep the geosmin level very low for the whole system.
This is our oxygen generator.
It delivers pressurized oxygen to the highly efficient ozone generator, newly developed by the company Water, where O2 is converted to O3. This cone is supplied with water pumped from the fish tanks, and the ozone gas is dissolved in the water where it will attack any organic matter, including geosmin, bacteria, and vira. After ozone treatment, the water runs through a pipe equipped with an ultraviolet device, which secures that no ozone will be present in the water before it is returned to the fish tanks. The pipe is further equipped with 2 newly developed OxyGuard ozone sensors, one before and one after the ultraviolet device. The ozone sensors deliver data to the OxyGuard Pacific unit, which monitor and control all equipment in the system, enabling adjustment of pressure, pumps, valves, and amount of ozone delivered.
Right here we're controlling the ozone, and we can see the levels is fine right now. If the ozone level is too high, it can cut off the ozone generator, so we only get the O2 to the oxygen cone.
For the purpose of this demonstration, the Pacific also receives data from sensors in the treated water, like pH and redox, temperature and oxygen saturation, total gas pressure and CO2. Samples of water and fish are regularly taken. Some tests, like bacterial counts, optical density and other chemical tests, are performed on-site. Others, like geosmin, are sent to Copenhagen University to be analysed.
Let me check something. Oops. The reason why we do it is to quantify the bacteria activity in the water from the fish tanks.
Here it is filmed in a freshwater tank before treatment and after the water has passed through the treatment system just one time. After it was successfully proven that the devices did remove the geosmin in fresh water, all the equipment was taken to the saltwater section, where the bigger fish grow.
We have now successfully demonstrated that our equipment is well suited for treating saltwater as well as freshwater. In the saltwater department, we were now able to stop before we accidentally may create any bromide salts.
Apart from minimizing the muddy taste in fish flesh, there will be big savings in the amount of water used today for purging, before the fish is harvested and presented for the customers. The aim is to have the system ready to be implemented in the aquaculture industry within a year or so. This is another step of improvement for the most sustainable way of producing protein for human consumption. Aquaculture.